It's a vibration that travels through the medium, like air or water. If you drop a rock into a bucket of water, you disturb the surface of the water and create ripples or waves which travel away from the impact. The ripples cause the height of the water to change, going up and down, as the wave moves away from the splash. These waves are visible with our eyes and have a number of properties. They have a maximum point, called a crest, a minimum point, called a trough. They have a wavelength, which is the distance from a particular crest to the next one. They have an amplitude, which is the distance from the center line to the top of a crest or to the bottom of a trough. They have a frequency, which is the number of waves that pass a fixed point per second. They have a speed, which is just wavelength times frequency, and they have a direction. Sound waves are similar. If you clap your hands in a quiet room, you will disturb the air and cause ripples of air to move away from your hands. The clap disturbs the air molecules near your hands. These molecules then bounce into other nearby molecules, and so on, so that the disturbance moves through the air like a wave, a sound wave. But sound waves are different to water waves in one respect. Water waves are transverse. This means that as the wave is moving in one direction, say to the right, it's creating a disturbance in the perpendicular direction, so up and down. Sound waves, on the other hand, are longitudinal. This means that as the wave is moving in one direction, say to the right, it's creating a disturbance in that same direction, so left to right. A transverse wave coming from behind lifts you up and then drops you down like a boat in the ocean, while a longitudinal wave coming from behind pushes you forward and then pulls you back like a spring. But when representing sound waves graphically, it's easy to draw them as transverse waves, so that it just looks like a regular sine graph. But really, this sine wave is the motion of the air particle as it travels through time. Another way of presenting this is that the low points on the sine wave are where air particles are spread far apart, and the high points on the sine wave are where air particles are bunched together. Sound waves cause changes in air pressure as particles bunch together and spread apart. Now, we can't see these ripples, but our ears can hear them. When the waves reach our ears, the air pressure goes up and down, and this makes our eardrums go in and out at the same rate. Our brain analyzes these signals and interprets them as sound. Otherwise, sound waves have all the same features as water waves. They have a speed, which is naturally the speed of sound, or roughly 343 meters per second through air. And they have a frequency and a wavelength, which determines the pitch of the sound, where the shorter the wavelength, the higher the frequency, and the higher the pitch of the note. And they have an amplitude, which is the energy of the wave, and affects the volume of the sound, though it's actually a bit more complex than this. In the next few videos, we'll go into these topics in a bit more depth.
Okay, شباب. So I want from you to remember just different informations, okay, that have been mentioned in this video. Okay, I'll say names and you have to reply, and no one, please reply the answer of his friend, try to say new answers. Okay, we'll start with Ahmed Al-Manki. You can unmute yourself, Ahmed.
Yes, teacher.
Can you say any information from this video?
I cannot see anything. I see black screen.
No, the video has ended already.
Oh.
Did you watch the video?
No.
Why?
My mother called me to do the TV.
You are in a class now.
Yeah, I joined. I stayed a bit, then my mother called me. I went to do the TV, come back, and you say watch video.
اوكي يا احمد. الحسام you can unmute yourself. الحسام you can unmute yourself. You can talk. حسام مصطفى. حسام. حسام. Okay, it means you are absent, Hassan. You are absent today. Okay, Dr. Saeed. Where's Dr.
Teacher, the sound wave is that can travel on way to the matter.
Can travel in what?
Any
In
only thought in any only the matters.
only matter, yes. It needs a matter or a medium to propagate or transfer through. Okay,
Yes, and
okay.
it can matter solid and liquid and gas.
Yes, like liquid, gas, and solid. Excellent. Okay, thanks, Abakr. Okay, Mazen. Mazen. Okay, you can unmute yourself.
Yes, teacher. I have some points that I get from the video. The first point that the sound disturbs the particles in the air.
Yes, excellent. It make a disturbance in air particles. Okay, excellent.
Yes.
What else?
And about the sound waves, the maximum point in the wave called, I think, I forgot what's.
Crest.
Yes.
It's like the crest of mountain. It's crest. Okay.
Okay. And the minimum point is called trough or
Trough. Yes, trough.
Yes. And the distance between the wave and the wave is called wavelength.
Wavelength. Excellent.
Yes.
Okay.
That's what I get, teacher.
Okay. Thanks. Thanks. Okay. Anyone else? Abdullah Abdulaziz. You can unmute yourself. Abdullah Abdulaziz.
أيوة.
Yes, Abdullah. Tell us an information from this video.
Huh?
Tell us an information from this video. You watched about 3 or 4 minutes video. I'm asking for only one information
Echo.
from the
The
video.
repeating of the sound.
No, echo is not mentioned in the video.
Because I just now enter. I don't see the video thus.
Or just 12 minutes now.
Yes, I just enter. I didn't see the video.
Okay, what is the meaning of echo?
The repeating of the sound wave.
Okay. The repeatedness of hearing what sound waves. Okay. Thanks. Okay, Shabab. Who can talk about sound wave? Raise your hands. Who can talk about sound waves? Samir Muhammad Al-Khwaytani. Samir, you can unmute yourself.
Yes, Mr. Hello.
Can you talk about sound wave, please?
I have just entered the.
Okay, no problem. You talked this last year. Okay, I'm asking about what you remember about sound wave. What do you remember about sound in general?
I can't hear you, Mr. Can you raise your
What
voice?
do you remember about sound in general?
I don't remember.
You don't know anything about sound?
No.
What is the nature of sound?
I don't.
What is the speed of sound? Where it can travel?
Yes, I can't hear you. Your voice is not clear.
Okay. Faisal Yusuf.
Mister, I will go out and then come back.
Okay. Faisal Yusuf.
Yes.
Yes, Yusuf, can you talk about sound wave?
Yes.
Yes, please.
I
Tell us.
say anything about sound wave.
Yes, anything you can remember from last year about sound wave.
Echo?
Okay, what does it mean, echo?
Kind of sound wave.
No. Okay, sure. You can mute yourself. Okay. Ahmad Al-Malki. Ahmad Al-Malki. You can unmute yourself, ya Ahmad.
Yes, I unmute myself.
Okay.
Teacher, sound waves are waves caused by vibration that can only travel through matter.
Excellent. So sound waves are vibrations. The sound is caused by vibrations, okay, or a vibrator or an object that vibrates and produces what? Vibrations that propagate through medium like air. Okay, excellent. What else? You muted yourself again? Unmute yourself, Ahmed.
Yes, yes, I am mute.
What else, Ahmed?
Sound waves can come in different volumes.
Different volume. Okay, we can control the volume of the sound wave. Okay, excellent. Yeah, thanks. Yeah. Mazen.
Yes, teacher, I have 2 points. The first, like they said, the sound waves can travel through the gas and the liquid and the solid, but the sound waves can't move the objects.
Yes, can't move the object. Okay, okay.
I
So the
and
particles of the medium itself, right? I mean, مثلا particles of air,
yes,
it does not move, right? They just transfer the sound wave. Okay, excellent,
I don't know,
excellent.
but teacher, I said that they make a distribution.
Disturbance. Yes,
Sorry.
disturbance. Okay, they make
Yes.
them vibrate. They don't change their position. They only vibrate, like when you are twisting right and left, and you're still standing still on your feet, right?
Yes.
It's like
Yes.
vibration like this one. Okay,
Okay.
thanks, Mazen.
Teacher, I have an example.
Yes, you can take.
About the bats. The bats use sound waves to find their way to fly and to find their prey.
Yes, bats, they use sound waves to detect the barriers, okay, in front of them, so they can avoid barriers and can detect any object, okay, so they can fly. So bats cannot see, but they use what? A sound wave. Excellent, excellent, thanks. Okay, so we'll just move for many different terms about sound. First, what does it mean, a sound wave? Okay. Here you can find the definition of a sound wave. A sound wave first is a longitudinal wave that can travel only through matter. And we also can say it is mechanical wave. It is mechanical wave. Mechanical means it needs a medium to move through or to propagate through. Okay? Yeah, for example, sound can travel or propagate through air or gases in general, through liquids, through solids. But can sound travel in space? Who can answer this question? Can sound travel in space or move in space? Yes, Yamazin. Can sound travel in space?
No, teacher, because there is no air in
Yes, there is
space.
no medium. There is no medium in the air. So sound wave is a mechanical wave. Mechanical means it needs a medium to propagate through. It needs medium like water, like air, like solid. Okay? Thank you, Master. Okay. So this is the first term is what does we mean by a sound wave. Okay. How sound is produced? Sound is produced, okay. And here at the left you can see the meaning of longitudinal wave. a wave in which particles in a material move along the same direction that the wave travels. Okay, so we need particles. Okay. Here, as you said, it, vibrating objects produce sound waves. So how can we produce sound? When you knock on anything, if you use your ruler and you hit on it, it will vibrate or move to and fro, okay, and producing what? Sound wave, or a sound we can hear. So to have a sound, we must have a vibrating object. How can we talk? By vocal cords. These vocal cords are vibrating inside our throat, right? So when they vibrate, they produce our sound. Okay, move to another point. Here, vibrations and sound, as we said, some objects such as doors, drums vibrate when you hit them. For example, when you hit a drum, the drum moves up and down or vibrates. These vibrations produce sound waves by moving molecules in air. Okay, the sound waves has two regions. Sound waves has two regions. Okay, these regions we name them compressions and rarefactions. Compressions and rarefactions. Who can remind us what is compressions and what is rarefactions, if you remember? And you can find it in front of you in this small paragraph. Raise your hands. What does it mean? Compressions and rarefactions. Okay, you can unmute yourself, talk. Amazing.
As teacher, as I'm seeing now, compressions is when the particles join together or be closer to each other, and
Yes.
rarefactions, yes, is when the particles move away a little bit from each other.
Yes, excellent, excellent. So as you can see here, Shabab, in this picture, at the middle here, you can see particles are getting near or close to each other. This region, we call it what? Compression, from compressed like pressure, okay? Then these particles can push the next particles, okay? So the wave can move. This region where the particles are away from each other, this one, it's called what? Rarefaction, where the particles are away from each other. Okay, so what are compressions and rarefactions? Regions in the sound wave, compressions where particles are close to each other, rarefaction, and particles when regions where the particles are far away from each other. Okay, the wavelengths and frequency. Wavelengths and frequency. Look to this picture and try to understand, and I'll ask you, what does it mean, sound, wavelengths and frequency? From this paragraph, you can extract the meaning of wavelengths and frequency. Read this paragraph and tell me the name of wavelengths and frequency. What does it mean? Okay, this time I'll okay, Ahmad Al-Malki, you can unmute yourself.
Sir, where is the paragraph?
You cannot see the paragraph here?
I see black screen.
Ah, okay, Ahmad, you can go out and come back in. Okay, you can go out, log out, and then come back again, okay? Okay, another one. Hussam, you can unmute yourself, Hussam.
السلام عليكم السلام.
Alaikum assalam.
Wavelength is the distance between a point on a wave and the nearest point, just like it.
Yes, يعني for example here, where the points are like each other, like rarefaction and rarefaction, right? The distance between rarefaction and rarefaction, what we call wavelength.
Wavelength.
Excellent. And the same, we have here compression and we have here compression. The distance between the middle of a compression to the middle of the compression or to the same point, also we call it what? Wavelength. So in general, distance between two same points, even compression, rarefaction, as we'll see in transverse wave is like water waves that move up and down like this one, like water waves. Also, the wavelength is the distance between crest here, okay, crest, and the other crest. This also called what? A wavelength, or between trough and trough. Between is distance between two same successive points. Successive means they come after each other, just the next one like it, okay? I hope it's clear for everyone. What does it mean, wavelengths? Any other one again want to understand the meaning of wavelengths? Okay. Come to a point, frequency. Come to the point, frequency. What is frequency, Shabab? Okay, Abdullah, Abdulaziz. What is the meaning of frequency? You can unmute yourself. Abdullah Abdulaziz. Unmute yourself, Abdullah.
Yes.
Yes, Abdullah. What is the meaning of frequency?
Frequency.
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 Yes.
Uh,
You can find it in this paragraph. Yeah.
is the number of wavelengths that pass given point in 1 second.
Yes, a sound waves frequency. Here we are talking about is the number of wavelengths that pass a given point in 1 second. What does it mean? If we say this is in this distance, there is the wavelength, okay, maybe in 1 second we have 10 wavelengths, we have 20 wavelengths, we have 100 wavelengths, okay? So it means frequency means a number of wavelengths, the number of wavelengths, okay, that passes in a point in 1 second, okay? Abdul Rahman Sultan, it is now 8:27. It is now 8:27. Late 27 minutes. How you can come now? Okay, Ahmad Al-Malki, you can see the screen now, Ahmad?
Yes, I see it now.
Okay. Okay, Shabab. If we move back to the video, we can find what I'm talking about here.
Medium, like air or water. If you drop a rock into a bucket of water, you disturb the surface of the water and create ripples or waves which travel away from the impact. The ripples cause the height of the water to change, going up and down, as the wave moves away from the splash. These waves are visible with our eyes and have a number of properties. They have a maximum point called a crest, a minimum point called a trough. They have a wavelength, which is the distance from a particular crest to the next one. They have an amplitude, which is the distance from the center line to the top of a crest or to the bottom of a trough. They have a frequency, which is the number of waves that pass a fixed point per second.
So here again, Shabab, so if you can see, if we have another kind of wave that produced in water waves, we have crest and trough. They are like water waves. We call them transverse waves, but just now know it's like the water waves. We have the highest point here. We call them trough. Sorry, crest. This point and this point. So the wavelengths, the distance between two crests. Okay, and here trough and trough. Okay, so also the wavelength, the distance between two troughs. You've got two same point, and they must be next to each other. And this is number one, is crest number one and crest number two. If we can complete here, we can have crest number three. What is the wavelength? No, the wavelength is the distance between crest number one and crest number two, or trough number one and trough number two. Okay, must be successive, you know, it comes after each other. Okay, suppose the time from this point, from here, can change color. The time taken by the wave from this point to this point, from this one. So here in this distance, how many waves we have? This is the first wavelength, and from here to here, this is the second wavelength. Okay, suppose the time here 1 second, 1 second. So we are talking about frequency. So frequency means a number of waves that pass in a point in 1 second. So the wavelength here, we can say we have 2. So the frequency is 2. The frequency is 2. 2 means we have 2 wavelengths. This wavelength number 1 and this wavelength number 2. So frequency in number of wavelengths that pass in a point in 1 second. And the measuring point of frequency is hertz. Its symbol is Hz. Okay, the frequency is measured in hertz and its symbol Hz. So frequency into hertz. Okay, do you have any questions in this graph, Shabab, to ask about? Please raise your hands if you have any questions here. Okay, Ahmed.
I don't understand. What is amplitude?
Sorry again, Ahmed.
What is amplitude?
Yes, amplitude. I didn't say, but what I said, you understand? Wavelength, crest, trough, frequency.
Yes.
Okay. Okay. Before we move to another one, we say amplitude. Amplitude, where you can find this point? This point in the middle. Okay, there is no disturbance in the medium where the particles. You can see he represented this red point. It means the particles of the medium, maybe particles of water. Okay, this red one. This is the rest point. We call it rest point. What is the meaning of rest? Yeah, when there is no movement. Okay, if we make a line from this rest point to the maximum point that the wave reach, we call it what? Amplitude. Amplitude, yani the maximum distance from the rest point, okay, that the particles can reach. And you can say as this amplitude, but from the rest point to the highest, to the deepest of trough, or from here to the highest of a crest. Also from this point to the deep point of a trough, or from this point to the high point of a crest. This is what amplitude. The maximum displacement. Maximum displacement that the wave can do. Okay, do you have questions, Shabab? Still Mazen? Yes, Mazen. If you have question.
Teacher, sorry, but I didn't understand the frequency.
A frequency. Suppose the time taken from this point, which is here, from this crest, okay, to this what? Crest is 1 second, okay? The wave is moving, okay? The move takes this distance in 1 second, okay? We will count the wavelengths here. How many wavelengths here? Crest to the next crest. How many wavelengths? 1.
Here we have 1, yes.
And from 2 to 3, how many wavelengths?
1.
1. So the total wavelength here is what?
2.
2. So the frequency is 2.
2
wavelengths. Hertz. Hertz means vibrations, 2 vibrations. Okay, you can understand by this one. So the frequency in numbers is the number of waves, waves in 1 second. So we will count the number of waves in 1 second. This frequency. Okay.
Okay.
Okay, guys. Do you have any other questions? Any other one has any other questions? Means you understand. So can I ask? Samir Muhammad, again, I'll come back to you, Samir. Samir Muhammad, this time if you didn't reply, consider you absent for this period. Samir, you can unmute
Yes.
yourself. Yes, yes, Samir. Can you explain to us again what is the meaning of frequency?
Okay.
Hmm.
1 minute.
Why won't it?
I want to remember.
What's remember? We just said right now many times. Okay, Samir. I said you didn't understand, you can ask again. Frequency. Okay, we will count the number of wavelengths. How many wavelengths here? We have from this point to this point, 1 wavelength. And from this point, number 2 to this point, number 3, we have another wavelength. So how many wavelengths? 2. How many wavelengths? 2. We count this, the number of wave in 1 second, in 1 second. So is this, in 1 second, we have 2 wavelengths. So the frequency is 2 hertz. The frequency is 2 hertz. 2 the number of waves. Okay, hope you understand this point. Okay, can complete watching the video.
Which is just wavelength times frequency, and they have a direction. Sound waves are similar. If you clap your hands in a quiet room, you will disturb the air and cause ripples of air to move away from your hands. The clap disturbs the air molecules in your hands. These molecules then bounce into other nearby molecules, and so on, so that the disturbance moves through the air like a wave, a sound wave. But sound waves are different to water waves in one respect. Water waves are transverse. This means that as the wave is moving in one direction, say to the right, it's creating a disturbance in the perpendicular direction, so up and down. Sound waves, on the other hand, are longitudinal. This means that as the wave is moving in one direction, say to the right, it's creating a disturbance in that same direction, so left to right. A transverse wave coming from behind lifts you up and then drops you down like a boat in the ocean, while a longitudinal wave coming from behind pushes you forward and then pulls you back like a spring. But when representing sound waves graphically, it's easier to draw them as transverse waves, so that it just looks like a regular sine graph. But really, this sine wave is the motion of the air particle as it travels through time. Another way of presenting this is that the low points on the sine wave are where air particles are spread far apart, and the high points on the sine wave are where air particles are bunched together. Sound waves cause changes in air pressure as particles bunch together and spread apart. Now, we can't see these ripples, but our ears can hear them. When the waves reach our ears, the air pressure goes up and down, and this makes our eardrums go in and out at the same rate. Our brain analyzes these signals and interprets them as sound. Otherwise, sound waves have all the same features as water waves. They have a speed, which is naturally the speed of sound, or roughly 343 meters per second through air. And they have a frequency and a wavelength, which determines the pitch of the sound, where the shorter the wavelength, the higher the frequency, and the higher the pitch of the note. And they have an amplitude, which is the energy of the wave, and affects the volume of the sound, though it's actually a bit more complex than this. In the next few videos, we'll go into these topics in a bit more depth.
Okay, Bakr Said. Yes, yeah, Bakr.
Teacher,
Yes, Bakr.
someone, his name is Wissam, he can't come to the period.
Yes, he is coming after 30 minutes of the period. I said you have only 5 minutes to log in.
Okay.
Okay, so he will attend the 7 or 5 minutes to consider him attendance. No, sorry. Okay, you have only 5 minutes. You have also, yeah, in successive periods, you have 5 minutes between each period. And I give you extra 5, so you have 10 minutes, okay, between periods to log in. Okay, so no excuse to be late. You have
Okay.
to tell him that and tell the rest of your friends. Okay, thanks, Abak. Okay, Shabab, we finished our session today. Hope you enjoyed it. And if you have tried to revise this lesson, if you have any questions, you can ask in the next period, inshallah. Okay, see you.